The next important contribution is that of Eratosthenes, who was the first to determine the circumference of the Earth or the radius of the Earth. So he lived from 276 BC to 195 BC. He determined the circumference C, that is the radius R, because the two are related by the well-known relation. The circumference of the circle is given in terms of its radius as 2 pi, where pi is that transcendental number, 3.1415, and so on. The decimal places continue forever times the radius. So if you know the radius, you know the circumference. If you know circumference, you know the radius. The connection is this number 2 pi. And he did that by using geometry and observations. Now, there is a fundamental fact from Euclidean geometry and that is if I have two parallel lines and then if I intersect them with any other straight line, then this angle here is equal to this angle here, is equal to this angle here, is equal to this angle here. They are all equal angles. Now, what is the observation that he used? So here is the observation. Okay, so at noon on summer solstice, the sunlight comes directly down and actually you can see the bottom of the well. Now, some distance away, in nearby Alexandria, there was a monument, an obelisk. And because it was away from Cayenne, and the sunlight, of course, the sun rays are always mutually parallel, it cast a shadow. Right? Now I can extend this line down the well all the way to the center of the Earth. And also I can extend the line given by the obelisk, a monument, all the way to the center of the Earth. Now, what you have here is that, again, this situation from geometry. These two lines, given by the direction of the sunlight, are parallel to each other. And this line here, along the monument, is crossing these two parallel lines. So you conclude that this angle here must be the same as the angle there. But you can determine this angle here from geometry using the height of the monument, which is known, and the length of the shadow. which you can measure, right? You can measure the length of the shadow. So let me just isolate this here. So this is locally the monument of known height. The sunlight locally here is at an angle, and the monument will cast a shadow of known length S, and then angle A can be found from the height of the monument and the length of the shadow. Of course, needless to say, this angle here is 90 degrees, so you're dealing with a right angle triangle. At any rate, so from these measurements, you can determine the size of this angle, that is the size of this angle. And then you can measure the distance between Cayenne and Alexandria, D. And then you know that the ratio of that distance between Cayenne, or the well, and the monument over the circumference of the Earth must be in the same proportion as this angle here, A, over 360 degrees. So you can measure right? So the distance between the well and the monument over the entire circumference of the Earth is in the same proportion as this angle here between these two directions and the full circle of 360 degrees. And from this, right, so you determine the angle, you measure the distance, and using this relation, you can find the circumference of the Earth, and therefore the radius, if you solve this for C, you get that it is D times 360 over A. At that time, the unit for length was not meter, kilometer, or mile, but the unit was called the stadium. So there were so many stadia between Cayenne, where the well was, and Alexandria, where the monument was. Now, for a while, there was some dispute because there were two values for the stadia, right, for the stadium. But it now looks that basically the value that he got was actually quite accurate. He was able to determine the circumference of the Earth very accurately. Now, here again, just like in the case of arguments proposed by Aristarchus, you have a perfect example of very sound scientific reasoning and approach, right? You use the observation, you use geometry in all of its quantitative features, you use its theorems and various geometrical relations to actually deduce from observations the quantity that you want to find. In this case here, the circumference of the Earth. Right? So there's nothing, absolutely nothing wrong. This kind of observation / experiment and deduction is perfectly valid today. I mean, any scientist today would have been proud if he did this.